Good afternoon, everyone. This is Christina Fugis, Editorial Director with Mold Making Technology magazine. Welcome to our webinar, sponsored by Mold Making Technology and CimatronE Technologies. Our topic this afternoon is Mold Design Keys to Success. A few mold design strategies can go a long way to ensure you deliver top quality molds in a timely manner. The success of a mold manufacturer boils down to its ability to deliver high-quality products at the shortest time and lowest cost possible. This webinar will review some mold design best practices from both the technology supplier and end user that will help you achieve these goals. Our first presenter this afternoon is Dan Branch, Support Manager for CimatronE. Dan has more than 15 years of tooling experience, and while working for CimatronE, he has been assisting mold makers identify and implement improved design and manufacturing processes, as well as providing customers with world-class technical support. Dan will be followed by Tom Bergman, who is Vice President of Manufacturing for Aluminum Injection Mold, an industry leader in providing creative solutions in plastic to a wide range of customers, including automotive, medical, computer business, telecommunications, and consumer products. For 25 years, Tom has been a pioneer, along with his business partner, Jerry Ayers, in the use of building and running aluminum molds. A business owner and partner in AIM for 5 years, Tom works in all corners of the business, from mold and part quoting, mold design, mold build, and mold processing of aluminum injection molds for low production, high volume production, bridge, and prototype molds. Keep in mind, as we listen to Dan and Tom's presentation, you're free to ask questions by typing them in the questions pane on your computer. Dan and Tom will answer them at the end of the presentation. As a reminder, this webinar is being recorded, so you will be able to listen to it online later. Thanks again for taking time to be with us today, and we'll begin. Here's Dan.
Thanks. So to get started, I would like to take a minute to tell you a little bit about us. CimatronE is a world leader in CAD/CAM solutions for mold, tool, and die makers, as well as manufacturers of discrete parts. It happens that this year we celebrate our 30th anniversary. We have loyal customers in 35 countries and over 40,000 installs in place. Companies using CimatronE, they design and build a wide range of products. Our global presence means that we can often be found working with multinational companies in a variety of markets, and we help them find the solutions that they need. Not long ago, Aberdeen, an independent research group, conducted a survey on tooling delivery times. Delivery time is where the real competition is for new tooling, and we recognize it as a critical measurement. So we're very happy to say that shops using CimatronE will typically outperform even the best rated shops in this regard. In our presentation today, we want to elaborate more on some points that we first laid out in an article published in the December issue of Mold Making Technology magazine. And we're going to start with total process thinking. If the goal is truly to deliver on time and better than the other guy, then there's no room for any holdups in your system. New technologies can and do make for a better process, but only when they streamline the job flow rather than reroute it to some other spot. CimatronE CAD/CAM software covers every facet of quote, of design, and of manufacture. It's our goal to provide the best functionality for the task at hand, while always keeping the next task in mind. When delivery times are compressed, seamless flow is essential. So jobs move quickly from part analysis and quote to tool design to NC programming and electrode design. Now, seamless flow does not, however, mean that the process must be linear, and that's important. The way to add efficiency is to facilitate every task with enough initial data to get started, and then keep those doors open and information flowing to simultaneous activities. And it's possible when using a unified CAD/CAM package that understands the needs of tooling and is built with this total process in mind. When it comes to quoting for tooling, which is our other point here, you're going to need a lot of information from a part and not a lot of time. Part size, volume, projected area, these all help you determine the mold size and the press that will accommodate it. Mapping techniques can be used. They can show curvature on surfaces. They can show smoothness problems on surfaces. And we can talk about analysis of draft angles. These will quickly identify problem areas for molding, as well as highlight undercut areas that add complexity to the tooling. This is my first opportunity to switch over to CimatronE itself. And here I want to show a little bit about draft angle analysis on an example part. So the system will consider a direction for mold draw. Let's go in there. And what we have is a colored display that allows potential problems to easily be found. Here we're looking in one direction, like from the top. We can even use the cursor to give specific information on certain angles. So let's say on the back of this part, we could look around and possibly find problem areas that are very difficult to see just with the eye. So in this case, any going red is going to indicate areas that cannot be molded along the main direction of draw and might require more expensive cams or lifters. On the screen now is what we call Mold Quote Generator. The CimatronE Mold Quote Generator is another application to help mold makers achieve more accurate quotations by using the project details from CimatronE and also the cost-related details from your prior experience. All of this goes into a database. It's used to store your quoted work, and when combined with standard practices and components, can estimate the labor and material cost. We can adjust a lot of things in this product, but again, it learns from the previous molds that you've designed. They stay in the database, and there's a link to the data that you're getting out of CimatronE. We'll come back to our presentation for a second to move on to the next point, and that is standardization. Whenever possible, that was a point that we laid out in our December article as well. And what it means is a lot more than purchasing off-the-shelf components. It means striving for efficiency by finding repeatable patterns of design and methods of machining. CimatronE makes it easy to use the components from previous tool designs and provides a template mechanism that repeats your favorite styles of NC or of electrode design or even drafting. I want to demonstrate a little with that. So in a 3D environment, any work you've done already to prepare for quote is saved for tool design. On screen right now is a layout of both left and right-hand versions of the part. Stuff that was easily placed in for quote can be edited. We can look at some standard components here. So these might be from common industry suppliers, or we have an easily customized table CimatronE developed for tool and die makers alike who build in-house standards. Either way, edits to the quoted starting point are easy to apply as the tool design progresses. So let's come down to just the parts here. One of the best tools in the CAD industry for finding parting lines is CimatronE's Quick Split. Regardless of the part quality, this is an analysis that scans every surface, and even minute problems that may have been previously overlooked are going to be brought to light. Again, we have a vector to determine the direction of draw, and we run the analysis. The draft angle analysis is also in here if we want to take a look at that, but we've already seen it. What I want to point out here is this area in yellow and even these edges in pink. It's very small, so I'll have to zoom up quite a ways. But the bright yellow highlighted face is a face that's partially occluded by a very, very small overhang here. It's probably unintentional, but part mistakes like this have to be found early on in the tool design process. And Quick Split does help us do that. Let's accept that side. We'll flip the arrow over and take a look at the bottom. Again, run the analysis. So once we've got a little going here, we can open the part up, and we visually see a bit of the mold action that's going to take place very early on here just by dividing up these parts. Now anything that's left over is going to be something not assigned to cavity or core direction. These have to be looked at by a little bit further analysis. So we'll come back to another direction, and we'll make the vector from any number of things. Let's say normal to face, and pick a surface to start analysis here. So any number of these pull directions can be specified and then animated to see how they'll look in the tool. Let's move a little farther ahead. So we've been working on the tool design here, building some shutoff. Again, I'm going to access the Quick Split and get rid of one of the sets we've defined here so we can look at some of these other surfaces a little closer. Mold design is made up of many, many tasks, and creating shutoff faces around parting line is definitely an important one. Often this is complicated work, but good parting surface functions will save a lot of time. While design methods do vary, one common need is to extend the part faces while maintaining their natural shape, and Cimatron provides an excellent tool to do that. Basically, we can look at any surface and make an unlimited amount of adjustments to the boundary live and on the screen. So with a quick method of deleting some of those boundaries, we can now invent our own, much larger than before, which again gives us an excellent preview and natural extension of a parting face. Let me roll the part over here. Another really phenomenal function is for working on internal islands and areas. Come up here to close open gaps. What it's going to do is chain an internal boundary of any size and sort of extend and trim an entire area at once, which just saves an amazing amount of time versus shutting that off all at once. That pretty much makes the ideal pocket for that area. While all of this is going on, creating surfaces, design, shut off, any opportunity we have to order parts or to get machining started is going to compress those delivery times that we're talking about. So with very little data in place so far, what I want to do is show you a specialized tool we have for lifters or inserts, those kind of things. That's going to require pushing a couple buttons here. So let me turn on our ejection. Again, we had the mold base dropped in from the quote, and I'm going to go to Add Lifter, out to Standard Components. A lot to choose from here, and this is something we have developed out of the DME catalog. To add an assembly, we just want to create a few references from our geometry that we have here already. And then we can drop a point on the screen, make a few adjustments to the position. So we're doing this well before any official cavity blocks, core blocks have been defined. But we can start roughing this stuff in, and it's more than just roughing it in. We can actually use it from this point. So now that we've placed it in, I actually want to cut it to shape. And then again, I'm going to do this by referencing nothing more than the original data. We don't have the cavity, core, etc. defined. But we can say on this lifter blank, already we know we're going to need this shape, and to cut that on there. Let's take this idea even farther. We've got small built-in cutting objects created in the standard parts. So if we were to turn a few things on here and maybe do a dynamic section, you can see that we're getting a lot of design done rather quickly, pockets, etc. And more than that, the lifter itself can be sent right into CimatronNC to get machining started in the shop. So let's make some prep for that. Let's quickly define an axis for machining.
Welcome to GoToWebinar, Web Events Made Easy.
So like we were talking before about Save Technology and Cimatron helping you out, what we're going to do here is use a template. Templates from NC are saved from any previous cutting that you've ever done. If the general order of procedures is the same, then a template can be used over and over, regardless of changes in the size or the shape of what you're cutting. The geometry to be cut is recognized by color or any other criteria that you can really put in place. So let's apply from a number of templates I've got saved here. Here's one for lifter machining. This creates the toolpath that creates everything. We'll just execute it and see what we get here. So again, smart machining based on something I've done previously that was similar. So there's a few points. Our article touched on quite a few. Let's talk about one we're calling concurrent engineering. By our definition, concurrent engineering means getting the data processed through various tasks in the timeliest manner possible. This gets all the departments involved sooner and even provides for some flexibility when scheduling. In addition, many Cimatron customers have CAD stations placed around the shop. These are used for verifying dimensions, for cutter paths, even saves more engineering time when they can look stuff up themselves. Even receiving part changes, which is a very real and common occurrence, it has to be incorporated into all this design activity that we're doing with as little disruption as possible. That takes me back to Cimatron again to talk a little bit about processing and engineering change. So again, we've moved even farther down the design road here, but typically the case, the design is going to be well along when a part change comes in. We want to implement this change in the quickest possible fashion. So what we're going to do first is we're going to overlay the new part with the working model in the mold design. Turn off some of what we've done here. The part, of course, is still here waiting for us. And we'll browse out to the new data that we've received. Compensation for plastic shrinkage is a value stored in the design, and this is going to be applied to our new part automatically. We don't have to worry about that on the revision. And this resulting comparison, it shows a red and a blue color display. That's going to illustrate the new geometry being added and the old geometry being removed. We'll hide what we call the unchanged faces here, and you can really see a little better what are coincident with the old faces and then actually brand new geometry that's coming into the part here. Now, because of the associativity between this work part and the cavities that have already been designed, the system can next remove obsolete geometry right out of the design. It automatically understands only the mold components that are affected and only which surfaces need to be removed. So let's take a look at that. We'll ask to show what it's going to delete. And here's the pop-up. In the lifter, it found one face that's affected. In the A plate, a bunch of them. And in the B plate, a few also. So this, again, is going right down into the design that's in progress. And it's taking stuff out in preparation for adding new geometry in. I think we should take a quick look at that. So here's the part we were working on, and you can see that now a large quantity of that area is missing. Okay. Now that quick split function that we used earlier, it's going to help out again when we're processing this part change. All we really need to update now in the mold design is going to happen by assigning those surfaces into the existing knowledge of how the part was assigned and divided. So we'll add a little into the blue, the set that existed before. And to the bottom side as well. Maybe a few more here to clean up. We can open it up again, take a look at everything that's happened to the change, and that's good to go. Okay. New geometry has taken the place of the old geometry. Now, most real engineering changes, they're invariably going to affect not only the part, but parting line as well. So the current change adds this new window opening, and of course we do need to keep designing, add new shutoff in here, and fix a few things. So let's work on that very quickly, but we've already seen that Cimatron has functions that can help. In fact, we'll use the close open gaps from before to find that area, and we'll see that it can work to shut that off for us as well. So by bringing that change right into the design that's in progress, Cimatron is actually allowing you to avoid a bunch of time-consuming regeneration of parts and also the possible conflicts that can result from that regeneration. The last point I want to reference from our article has to do with designing a moving object. A static CAD environment is a challenging area. Mold designers like us have long grappled with this. Fortunately, CimatronE provides advanced motion simulation technology for mold kinematics. And it really features automatic recognition of common mold structures, also with comprehensive collision detection. There are very real benefits for providing this. They prevent common errors. They improve communication with the customers because you're able to see the things in motion. Let's take a look at that. We've got a little different design on screen here. So the motion analysis in CimatronE was conceived to actually understand the contact and the range of motion of the tool. In this example here, what we've already done for you is we've grouped the main systems of the mold together as fixed, as movable side, and a few other things that we see here in the lower dialog. We can run an initial collision test to make sure that no interference exists while the groups are at rest, like now. But then we define some motions. Now, the system set into motion a mold is by the opening of the molding press itself. So that's all you have to define. The dependent mechanisms, like lifters and slides we have here, they're driven by angled pins. You don't need to define those. The design itself guides their motion. Okay. So we'll set this into play. This is really true virtual tool building. I mean, any collision of components that happens is going to bring the halt to this simulation, and it's going to highlight the design area that caused it. There's a lot of things we can do with this dialogue. We can save it off to a movie. You can send it to your customer and say, here's what's going to happen. Try to zoom up as good as I can here so you can see that the slides do move back and forth. Lifters are taking place. This has really been a neat tool for us. Well, what I hope to illustrate here today is the CimatronE philosophy, really. CAD and CAM for the entire tooling process. Our customers are not just those in the mold business, really, but a worldwide spectrum of die and fixture, pattern, machine makers. You're going to find us anywhere. There's a need to work with data from a number of sources, then design and build the tooling to deliver the product. And we hope to help you do it in record time. That's kind of my review. I do want to hand off now our presentation to Tom Bergman.
Hello, everybody. This is Tom Bergman, and to tell you a little bit about our company, Aluminum Injection Mold is based near Rochester, New York, in Leroy, New York. We were founded in 1985. We are a pioneer in providing creative aluminum production molding solutions in the markets of automotive, computer, business machines, telecommunications, consumer products, and medical. The challenges that we face are keeping up with increasing short delivery times Now and again, we receive CAD models from customers that are often incomplete for molding. And the fact that because we build aluminum injection molds, there's a lack of off-the-shelf QC10 aluminum mold bases for us to purchase, so we have to produce our own. And having to create complex parting designs with few or no flat surfaces. So a few of the areas I will be focusing on today are areas AIM has streamlined in its operations. Our niche market, process and people, how we are machining, and how Cimatron plays a key role in our successes. We have a distinct advantage because we strictly build aluminum molds, and because of that, we have found that there are no off-the-shelf, as I mentioned, QC10 aluminum mold bases, which means that we design and build every mold in-house from the ground up. Some benefits of QC10 aluminum is its machinability, its through thickness hardness, the ability to high polish it, and its thermal conductivity allows for simple cooling patterns like you see on this photo of this mold we built. These water lines just go straight in and out, and we typically won't see more than a degree or two difference anywhere where you measure the temperature on that mold. Unlike most companies that have different people assigned to each task, AIM assigns one mold maker to handle a single project from start to finish. Instead of having one person do the design and then hand it off to someone else who's not familiar with it, we have the same person do the mold design and then machine the mold right up to completion. And that same person will even sample the mold in our molding press. Each employee has a complete understanding of what they are building. There are no surprises. They are building the mold they've designed, which leads to more efficient mold builds. Also, we can spot trouble early on in the mold design phase. When we get a customer's CAD file, as we're bringing it in, we can tell whether the CAD file might have some troubles in the mold phase, pointing to such things as wall thicknesses that might be too thick, or where they might not have enough draft and the part could hang up. It's a little more difficult to find individuals as our workers to meet these requirements because we are looking for people who can perform multiple tasks and take ownership of the entire project from start to finish. All our CNC machines and molding equipment at AIM are standardized on the same brand, so there are no variations in production or multiple types of machines to learn. Our control units on our CNC machines are all the same. There's nothing new to learn, so no time is wasted programming for one type of CNC versus another. And the same goes for our molding machines. They all have the same controller, so you can walk up to one controller, whether it's our 55-ton or our 300-ton, and it all works the same. And we do as much machine maintenance in-house as we can. We stock, for our CNCs, we stock off an extra spindle on the shelf. That way, in case one of our spindles goes down, we can change it over right away. And that's why we like the commonality between all our machines. CimatronE is great for our approach because we never have to leave the software, and we like to standardize that too in our process. We use it right from the beginning, from the quoting process, like Ben was talking about. When we get the customer's file, it's great for viewing and analyzing the part. If we need to do volume checks to see just the size of the plastic part, so we also have it not only for quoting mold build, but also quoting part molding. We have designed a few mold bases of our own in-house because we don't use standard mold bases, like I mentioned earlier, because we can't get them out of aluminum. So because we've designed a few of our own, with just a few mouse clicks, we can size up any mold base for any project. A couple clicks, mold base stretches, and we're ready to go with our mold base. CimatronE can work with incomplete customer CAD files that might come with surfaces missing or might not have drafts or certain radiuses. And that's where CimatronE is powerful, because we can take an incomplete CAD model and we can start working with it right away instead of losing time going back to the customer to say, can they fix and add a little bit of draft here. What we've always liked about CimatronE is that its ability to take a file that's a dummy as it's translated in, a customer's dummy solid file, and we can do solid functioning on it right away. And in particular, fan molds are a challenge for us because there's nothing flat. So all the shutoffs have to be created tend to be rolling and curving geometries with very little flatness. And we found that CimatronE has been very effective in doing that kind of shutoff work in the mold design. In addition, as I mentioned, some of the files come undrafted and we need to draft certain parts. We just had an issue yesterday with a mold design that was already complete, and we found some areas that didn't have draft, and instead of wasting time kicking it back to the customer to update the CAD model, we were able to go in very quickly and just modify that file, and we could get right back and get the mold finished up. So with all that being said, we found that using that approach with some of these solutions have helped shorten our deliveries, where we can turn around and deliver molds in weeks instead of months. I liked in particular what Dan had showed earlier about templates. An example of this picture here of this fan, we had consecutive jobs where we had built 3 fan molds, one right after the other, and we were able to use the templates from one, instead of going back and recalculating all the step overs and all the process for the machining. We were able to just pull the templates right in, and we were able to generate toolpaths in a very short time on the next fan, utilizing what we had done from the previous job. So I just wanted to say thank you for giving me a little bit of a time to show you about what we do and how we use CimatronE in our as a major tool for helping us get our work out the door. Thank you.
Thank you, Tom and Dan, very much for your presentations. Now it's time for some questions. I see that I do have some for both Dan and Tom, but before we get started, I want to remind everybody that you are still free to submit your questions, and you can do that by opening your question pane and typing in a question, and we'll get to them all, hopefully. All right, let's get to the first question. This one is for Dan. What kinds of data can CimatronE import?
That is a good question, and I will answer by saying CimatronE can import just about any kind of data out there. We still see the most common stuff being the STEP, the IGES, sometimes SAT files. We see that because everyone can read and write those types. But CimatronE also has direct converters. We can read ProE, we can read SolidWorks, we can read Unigraphics, CATIA, so it's quite possible that if you're dealing with an OEM of some sort, we can read their data directly. We find that helps out quite a bit.
What are some other functions CimatronE provides for mold makers?
You know, I didn't have time to really show everything that we could talk about. There are specific functions for runner design. There are some really nice functions for adding ejection, different types of ejection and cutting the pockets for those pins, blades, whatever. There is a cooling design module. So we've really, and besides the lifter and the insert that we looked at, we've really focused on mold making as one of our primary targets, and anything we can think of or that our customers can think of to help, that's what we'll work on.
I guess this one's for either Dan or Tom. With all the power, how long does it take for one to become proficient in using Cimatron? And is there a good way for someone to get started with something simple?
Well,
I know how I'd answer it, Tom, but go ahead.
Well, what we'd like to do is, obviously, when we want someone starting on a design, they obviously have already had the background in mold building, but we like to start them out with a more simple project that we're doing, let's say a mud unit that is enough for them to get a full understanding of the design, from, part splitting to the cooling pattern to the ejection, but it's just a little bit easier way to ease them into that transition of learning the mold design with an easier one like that. That helps boost their confidence of how they get better at it, and then just from that point on, we as they get farther along, we're ready to take them to the next level. We give them a job that's, let's say middle of the road as far as difficulty, but we try to ease them into it. We don't throw them the most difficult job with all kinds of action and lifters on it right off the bat.
Yep.
Tom, do you have anything to say?
Well, I'll add, Dan will, basically, I think Cimatron's right up there with the easiest CAD/CAM systems to learn. It's not something that takes years to master. I really like the approach AIM takes with very skilled guys, because they already know all the mold design stuff, and then it's just a matter of translating that to the CAD or the CAM. That would be the one thing about the learning time, is that there is a lot of functionality here. There's CAD, there's CAM, there's all these other, there's electrode. So, you jump into one of those areas first and you become proficient.
Well, how long would you say it would take for a new employee to get trained to do all of it?
I don't know, Tom, what do you think?
I would say it's going to take a couple of years, but one thing that I like about our approach is everybody here has a seat of the Cimatron. So you have people who are at different levels in their mold design, but the beauty is one guy can approach another guy to ask him for his help on how would he do this area. So we don't just have one person who's only doing it, and if he struggles with it, he might just struggle with it. We are very good at sharing with other people the best approach to do it, and I think that's what really works well for us, because we're big on not trying to keep our information that we know to ourselves with the individual. When we learn something new in Cimatron, we want to let everybody know within the company, did you know this function could do this? So I think we are pretty good at, we can bring along guys fairly quickly and they can pick up on it.
Tom, what kind of support have you needed from Cimatron to get where you are today?
Well, what I like Cimatron's tech support is we can, if we struggle with something that, whether it's we can't figure out on a machining end why we're getting the results we're getting, we can submit that to Cimatron's tech support, and it gets logged, and usually within a very short time we get an answer back as to what we need to get done, or why we're struggling with this, why we're not getting the results we needed. And usually it's not a limitation of the software, it's the limitation of the operator. We just didn't know how to do it.
All right, it looks like here I have a couple for Tom on, let's see if we can get through these. Would you consider aluminum molds for high cavitation, high volume medical parts?
Well, we always throw that in with a caveat. I mean, it always depends with what's the part geometry. I mean, it's a very general question, and I don't want to oversell aluminum. We don't ever want to do something, we say we can do X amount of parts, hundreds of thousands of parts, and it not be an issue. A lot of it is all how's the part geometry lend itself for the long-term shutting off? What's the resin? You know, there's certain resins that are very, very aluminum friendly, and there's other ones that the filled resins, glass-filled resins aren't so friendly for aluminum. But, you know, depending on what the part volumes are, certain mold coatings can be done to surface harden the aluminum. So it really comes down to those answers, and I would also throw in who's going to do the molding. And when I say that is, do they have experience running aluminum molds? You do have to be a little bit more sensitive to, you don't want to just, steel molds can take abuse a little bit because they're steel, hardened steel. Aluminum, you just have to be a little bit more cautious when you're setting up in the molding press. And a lot of our customers that we build aluminum molds for, they have experienced people running aluminum.
Are aluminum molds just for prototypes and low volume production?
Wide range. Yes, prototype, we build molds. We build bridge tools, so the production tool isn't going to be ready in time, but the customer needs to get the product out to market because they've already made commitments. So aluminum is a good option for that. And we have tools, a majority of the tools we build are production molds. It just, when I say production, it's the only mold that's going to be built, but the volumes might be 10 to 50,000 for the life of the tool, that's it. But we do have some molds for a customer in the area. We've built a first shot and a second shot mold where they've produced over 1 million pieces. And the reason they've been able to is it's a molding facility that's used to running aluminum, and they maintain the molds. When they need to do routine mold maintenance, they do that. And the material they're running is a very aluminum-friendly material. So, you know, again, I get back to it. It's all dependent on what the part geometry is, the resin, and who's going to be doing the molding.
That makes sense. Somebody is asking, what kind of aluminum do you use for your molds?
We use an Alcoa product called QC10 aluminum mold plate. It's an aerospace grade aluminum. It's a product that Alcoa came out about 6 years ago, and we like it a lot because of its through thickness hardness. Other aluminums were more surface hardened, but as you get through the thicker plates, the aluminum is not as hard, its hardness. Where the process that Alcoa makes this aluminum, the forging process, it's through thickness hardness. And what we found is it's great for when you're doing, removing a lot of material. It's unlike other aluminums, it's not under stress where you end up getting a lot of warpage when you remove large, vast amounts of the metal. And it has other great properties. It's great for high polish, takes textures well, and then it also brings its thermal conductivity that aluminum does. So not all aluminum plate, when people talk aluminum, just like there's different grades of steel, there are different grades of aluminum. And this QC10 is a high 7000 series aluminum plate.
Somebody is asking, how many parts can we get from this kind of aluminum mold?
Again, that's a very general question,
yeah.
and again, it all comes down to who's going to do the molding. I mean, I've been recently asked a quote from a customer on aluminum mold that we did not build. I will say that somebody else built that had gotten cracked. Now, I think the mold was very old, but my first question is what was that metal? What aluminum was it made from? And again, what was it can get a bad rap, but unfortunately it all depends, all these situations of, who's running it, and you just have to take a little extra care and caution when you're doing mold setup. But again, we've had molds where we've produced hundreds of thousands of pieces and they're still going fine. And we're venturing into some new areas with a customer where some materials that you wouldn't normally think to run in aluminum we have, and the customer is very open to seeing a lot more of this type of situation where we could run materials, that resins that typically wouldn't have thought that you could run in aluminum, you could. And their whole opinion about it is, well, let's see how many parts we can run off this mold.
They push it.
Yeah.
Here's another one for Tom.
Okay.
What's the average lead time for one of the fan molds? And they're asking that you break your answer down into design and build.
Well, typically what we do is we try to, right at the beginning of the design process, we size up what mold base size we need to do it in, and we order the metal right away. And so the time while the metal is waiting to show up, 3 to 4 days, our goal is to have the design done by the time the metal shows up, so that when the metal is hitting the floor at the shop floor here, we're ready to start cutting. And from the time we start cutting, a typical fan like was shown in that picture, we had plastic molded parts 4 weeks, I believe, from the time we got the order. Approximately 4 weeks.
Okay. All right. I want to remind
obviously, go ahead. But no, obviously that final answer there was all based on what our workload is. But that's the standard time for a typical job like that.
We have a little more time for a couple more questions if people are out there. So I want to remind everybody again that you can use that question pane. Also, as a reminder, this webinar was recorded, so you'll be able to listen to it if you happen to have missed any part of it at a later date online. I'm not sure if you answered this one already, but how long has AIM been using Cimatron for mold design and machining?
I've been using Cimatron, I think similar to, Dan mentioned 15 years. I've been using Cimatron for 15 years.
Okay.
And very pleased with the things that it's been designed for, specifically for our industry. They know the issues that we face when we get customer files that are not quite 100% and robust that you would like, and need a little work done to them, meaning some draft might be here, some fillets might be missing. And what I like about it is that we're working in the software right from the start. We can take the customer's file, and essentially once it's translated in, it's a dumb solid, meaning we can do solid functioning on sheet geometry, which when you tell people that, it kind of, well, don't you have to have a solid body to the part geometry? And not necessarily. I mean, just what I said, sheet geometry you can do solid functioning on. And again, it was made with the intent of knowing that you're going to struggle with a file that's been translated in from some other customer, and it's giving you the tools to help get the file up and ready to go so you can get going right into the mold design. And then what I like about it is that from right out of the design, we can just, on a click of a button, we're in machining mode, and we don't have to translate the file. We don't have to bring the the mold design into another software package for doing machining. If we have a change midstream into the job, we can like Dan was showing with the Eco Manager, we can bring in the new change and update it in the mold design, and then it updates and carries through right into the machining mode. And it really shaves off a lot of time, saves all that you're not jumping between different softwares to get your work done.
It's good to hear a customer of mine say those kind of things, because really when you think about it, Cimatron has been in the tooling business for so long now, and most of us on the staff are ex-mold designers or from the tooling industry of some sort. So all the functionality is aimed at that, and we know what the challenges are. We've had a lot of years to develop these good tools.
Looks like we have time for one more question. And again, it's back to Tom on the aluminum. What types of materials are not recommended for an aluminum mold?
Well, I would say any of the glass-filled, mineral-filled materials. And when I say not recommended, it does not mean that we haven't built molds to run those resins. We have. I always just, it always is dependent on what's the life of the tool. Some of the prototypes, like those fans that I showed you, those were in the realm of a prototype tool where they needed to do all kinds of air testing, spin testing, and they'd like to prove out their part design out of the real resin material before they go ahead and build their production mold. So those molds were molding a glass-filled material. So you can do it. Obviously, it comes down to what's the ultimate need of quantity of parts. What is the actual usage for the tool?
I'm going to sneak in one more, and this one's
Okay.
for Dan. This is for Dan. What is the typical learning curve to train a good mold designer to use Cimatron for full 3D mold design? And he wants you to assume the mold designer has already been using ProE or SolidWorks for several years.
Well, that actually is going to help. Not that we're the same as ProE or SolidWorks, but in my experience, every time you are exposed to CAD of some sort, you pick up from that. So it's a very hard question to answer. Obviously, it depends a lot on the person, but if I had to throw a number out there, I'd say that person should be designing molds in a couple months and really feeling confident with Cimatron after 6. The support staff is here to help guys like that out. We do a lot of training on the support line as well as talking about the software. So, between the tutorials and what the other guys in the company can teach you, as Tom was talking about at AIM, it doesn't take that long. You'll come along great.
Great. All right. I guess at this point, I want to thank Tom and Dan for your presentation and answering all the questions. For those who attended and you would like more information, you can contact Cimatron directly, and up on the screen is their phone number and email address and website. We appreciate your time in joining us. And I'd also like to take some time to thank the organizers for helping this presentation run so smoothly.